As our next example of applying Bernoulli's law, we'll consider a container filled with liquid that has a hole in the side of it. So let me erase a little bit to make a hole here. And so that means that there is liquid that's kind of gushing out of this hole. So this is liquid gushing out. And let's say that the hole is a distance h below the top surface of this. And the question is, what is the velocity with which the liquid gushes out of the hole? I'm going to ask you to attempt this problem on your own first. And I'm going to give you a little hint that note that, of course, at this point here, the pressure is 1 atmosphere. And also, let me use a different color here, at this point right after the liquid gushes out, the pressure is also 1 atmosphere because it's surrounded by the air. So now I will ask you to pause the video, try to work this problem on your own, and when you're done, or if you get stuck, then restart it. Okay, so using Bernoulli's equation, we have that 1/2 rho v1 squared plus rho gy1 plus p1 equals 1/2 rho v2 squared plus rho gy2 plus p2. And we will take the point at the top, that's our point 1, and this point here is point 2. So the pressures are the same at those 2 points, so we can cancel those out. The velocity up at the first point is 0, so this term goes to 0. And then we can rearrange to solve for our desired unknown, which is v2. We notice that each of the remaining terms has this common factor of rho, so we can cancel that out. And then rearrange to solve for v2. So v2, let's do it in 2 steps. v2 squared would be, what's left on the left side is gy1, and then I've got to subtract out this term here, the gy2, so y1 minus y2, like that. y1 minus y2, that's what we're calling h. And so v2, oh, I missed a factor of 1/2. This should be 1/2 v2 squared equals that. So v2 would be the square root of 2gh.